Welcome to this presentation on utilizing iMates. My name's Rusty Belcher. I just finished my Autodesk Certified Instructor training, and as part of that training I had to produce a couple of presentations and a couple of lesson plans for the class. I had to present these to my peers and to my instructor. And after I finished doing the work on these presentations, I figured I'd go ahead and record them and put them up on my YouTube page. If you are an Autodesk instructor and you're preparing for the ACI program, please remember that this is just a recording of my presentation. The ACI program is really centered on live instructor-led training. So this is just a recording of my screen during the training. Please keep that in mind when you review this information. Well, welcome to this presentation. My name is Rusty Belcher. The software that we're going to utilize today for today's presentation is Autodesk Inventor. And the module that this fits in is really the assembly/file management module. We're going to be utilizing iMates, which is a major function of Assemblies, but we're also going to talk about Inventor libraries. And that is a very file management centric topic. So this particular topic kind of bridges those two modules. Now, I believe that this is a fundamental level class as far as using iMates. Now, if you have to get into how to actually make iMates and add them to parts, then that becomes a moderate or advanced topic. It's important you understand that for today's lesson, we're just going to be talking about using iMates that already exist on parts. Now, I use this example, or both of these examples, in every Inventor Basics class I teach. So typically I cover this exercise on day 4. At that point, the students are familiar with part modeling and assembly modeling and a little bit of drawings. And the previous lesson, the lesson they just finished, is really the Inventor project file lesson. And that does lead in very well to a couple of the topics we're going to cover today. So let's go ahead and get started. So the overall goal for this presentation is going to be to create assemblies utilizing iMates. We have a couple of objectives that we're going to cover during our presentation today. Our first objective is going to be to utilize iMates to easily create a little Lego minifigure. I think many of you have played with Legos in the past and you're familiar with the Lego minifigure model, so we're going to use iMates to create that quickly and easily. We're also going to develop an office layout using library components that have been equipped with iMates. And you're going to hopefully be surprised at how easy it is to create assemblies utilizing iMates. So to get started, I got a question for the class, and it is, what do you consider to be the holy grail of CAD design? Think about your CAD tool and just dream about the ultimate version. If it's AutoCAD, if it's Revit, if it's Civil 3D, if it's Inventor, I want you to dream about what the ultimate version of that CAD tool would look like. I've heard many people come back and say that, you know, one of these days they're going to stick a wire in your ear and you're just going to think about it and bang, it'll be up on the screen ready to go. Well, maybe one day that's what will happen, but as far as manufacturing applications go, we have a term that we use for this ultra-simplistic version of CAD design. And that term has always, to me, has always been called Lego CAD. We have always wanted our CAD tools to work like those little plastic bricks we used to play with when we were kids. There's a couple of criteria when you talk about Lego CAD. When you talk about Lego CAD, you're talking about having your parts snap together like those little building bricks they used to play with. You want to have a very simple drag and drop methodology. Drag the parts together, they automatically pop together and fit together easily. You know, I have many clients that do not model anymore. They finished modeling the first year they purchased Inventor. And what they've been doing ever since is basically putting parts together in different configurations. Well, when they put those parts together, it needs to be as simple as possible. Lego CAD should be something that anyone could use. You don't have to be a hardcore Inventor graduate of the advanced program in order to use Lego CAD. Anybody should just be able to plop down in the seat, learn to turn on the tool, start dragging parts together, and utilize it very quickly and efficiently. And the workflow should be just kiss simple. Well, you know, I teach Inventor every month. I've taught Inventor a lot, and in every class I teach, we put the Lego figure together utilizing conventional constraints. Now, I recorded the process of putting this little Lego guy together using conventional constraints. And I'll play it up here on the screen, and I really wish I had a clicker for every time I make a pick or open a dialog box in this exercise. You know, it's a big lesson that Inventor users need to learn, is all the steps necessary to bring parts together. Look at this part right here. This part requires 3 constraints. It requires mate constraints and flush constraints, and you even have to go over and find out how to line the parts up middle to middle so that the parts are centered correctly. So there's a lot of steps using the conventional constraint process in order to get our parts together. We don't have time for that today. We need to be able to put this guy together in really less than 4 minutes in our upcoming exercise. And to do that, we're going to utilize iMates. Now, the question comes up real easy. What's an iMate? Well, an iMate is literally half of a constraint that is pre-placed on your parts to aid in constraining your assemblies together. These little white dots that you place on your parts, there's actually a symbol at the center of each one of them. I'll pull a little magnifying glass up here and let you see that. And that kind of speaks to the user and tells the user what parts can snap fit together. But I think it's pretty easy to see that the little arm is going to go to the arm socket and the wrist is going to go to the hand socket. And basically these constraints are pre-placed and ready to be used. Now let's talk about how you utilize an iMate. There's actually a gesture you're going to use when you utilize an iMate. You're going to select the component which will reveal the iMate. You're going to hold the Alt button and the left button down, and you're going to drag the iMate until the corresponding iMate highlights. You then let go of the mouse button and you let go of the Alt button. Again, if you want to see that again, let me jump back into this again. You select the component, you hold the Alt button down, and you left click and drag the iMate to its corresponding iMate. When they both light up, you simply let go of the button and then let go of the Alt button. So this brings us to our first objective. We want to utilize iMates to easily create the Lego minifigure. Now it is demo time, and I need you guys really to focus up on the screen. This gesture, it's going to take a couple of times for practice for you to get this gesture correct. So if you watch up on the screen, I'm going to do it for you multiple times. And get your hands off the mouse, focus up on the screen, and at this point I'm going to show you how to build the Lego man first, and then I'll let you guys do it again during the activity. So I'm going to open up my Inventor application, and I'm going to open up our exercise. I'm going to select File Open, and I'm going to go to my workspace. Under File Open, you can always get to your workspace right there. In your workspace, you're going to have a folder called Minifigure. All right, I want you to open up the Minifigure folder, and then you have an assembly file. I've got a lot of people in the class who are new to Inventor, so the assembly file icon actually looks like a stack of Lego bricks. But the file we're going to use is minifigure.iam. IAM stands for Inventor Assembly Model. So here's the exercise you're going to use. I've got all the components already pre-placed for you. And you can click the Home view. Orbiting inside of Inventor is just like orbiting inside of any other CAD tool. I've got the Shift button held down along with the wheel, and I can spin this around in any way, shape, or any orientation I want. I'm going to focus on the head first, and the first thing you do is select a component. Selecting the component is going to reveal the iMates that are on the part file. Now here's that gesture I mentioned before. I'm going to hold the Alt button down. Then I'm going to left click and drag the iMate at the neck down to its corresponding iMate. When you see them both highlight, you let go of the mouse and then you let go of the Alt button. And it's just that easy. It takes you a few moments, or it takes you a few turns to practice this, but once you have the process down, putting this little assembly together is extremely easy. Again, I hold the Alt button down, I drag the iMate to its corresponding iMate. I love this one. At this point, I can drag the iMate right through the body of the part to its corresponding iMate and hook it together very easily. You can drag the parts closer to each other just to make it a little simpler. Remember the little pelvis example here we did, where I mentioned before that in Inventor, this is 3 constraints that actually puts this together. Well, if you look at this particular symbol, this is the symbol of a composite iMate, which means it's actually going to do 3 constraints with a single click. This is an insert iMate. It looks like the symbol for an insert constraint. And you'll learn these little symbols the more you work with Inventor. But remember, this was a 3-step process in basic Inventor with basic constraints. And now all I have to do is drag it over to its corresponding iMate, and it pops together with a single command. I'll simply finish up by putting the legs on here. And in really no time at all, I've got a functioning Lego figure. You can sit there. I think many of you are going to have another minute or so to finish this up. So if you want to pre-position him, if you want to spin him around, make him look like he's walking, you are more than welcome. This is a fully functioning assembly at this point. So that's the exercise that I want you guys to do. Let me hop back over into Inventor. Now that I've finished the demo, let's get you guys working on the exercise. So the exercise, I've got it up on the screen. Remember, there's the minifigure subfolder. Go to your workspace, open up the minifigure subfolder, and then you'll find the minifigure.iam file. Just a couple of directions here. You want to use the iMates to assemble the Lego minifigure. Okay? Please remember, if early on, if you put a part together and it pops to the wrong hole, or something happens, you always have that undo button. Just reach up and click undo and try it again. I think early on you'll need a little practice with that gesture, but once you get it, putting this thing together is going to be a fairly straightforward process. And the gesture, again, for those of you, oops, sorry, get back. Remember the Alt left mouse drag gesture that you're going to be using throughout the presentation. So you guys are going to take about 4 minutes and put this together. I'm going to be walking around the room checking out everybody's progress. If you have problems with the exercise, slip up your hand. Let me know. I'll come and work with you and see what's going on, and we'll get this done as quickly as we can. All right, that was amazing. I really am impressed. You know, I've got a room here. We have some Inventor users in the room. We've got a number of architects in the room. We've got a number of Revit experts in the room. We've got a civil expert in the room. And I'm amazed how all of you were able to build that Inventor assembly on your first try. You know, welcome to Inventor. All right, you guys did fantastic. And I love this phrase. I just do. You now know enough to be really dangerous. All right. You've seen this simple workflow, and all of a sudden, vast opportunities are now open to us. You know, this workflow can be used. I can literally give this workflow to a salesperson. I can put Inventor on their laptop, send them out in the field, and have them go to a customer. Hey, Mr. Customer. I know you want this item configured a certain way. Why don't you look on my screen and we'll pop some parts together and we'll work out your configuration. You want option A, you want a side option of B and a couple of C's in here. These parts pop together. Is that what you want, Mr. Customer? Excellent. Let me send that back via email to my guys at the shop and get them working on that right now. And you can literally put this in the hands of sales staff. It's that easy to do. How about letting interns build assemblies for you? Many of us have summer intern help that come in every year. You give them a couple of days to get up to speed with your library of parts. And then on that third day, you've taught them Inventor. You drop down the stack of forms, which is all the configurations they need to build. They simply snap the parts together, get somebody to check it, and then they ship it out with a step file or an ACES file for another customer to use. And I love this next step, or this next bullet point. What about the people in the shop? You know, who in your company, who in your organization knows more about putting things together than the guys out in the shop? Well, this process is extremely easy. I can literally give a tradesman a computer and let them show me how things should go together. You know, you've got tradesmen who are in their last few years of before retirement. It'd be a great time to sit them down in an office environment with some of your young engineers and let them show the young engineers, this is why we build parts the way we build parts. You know, take advantage of this workflow so that you can get some of that mind share, some of that experience from your tradesmen into the hands of your young engineers. Well, that workflow is fantastic, but it is built upon an idea that you're going to utilize what we call a common part library. Once you have these parts set up, you're going to want to protect them in something like a common part library. Part libraries offer many benefits to CAD design. I mean, the first one is that this is a common place to go to use parts on various designs. I don't have to keep recreating the model if I can pull it from the library. And anytime we can promote component reuse, I mean, that's a good thing. Part libraries are often accessed by everybody in the organization. So this is a warehouse that we can all go pull from. They're nice and organized so that anybody, even those interns, can easily find the data and then get the data into their CAD system as easily as possible. And they are managed. So this is certainly an area where we'll talk about CAD management and file management, and these files are protected and backed up, and they are critical to our functionality and our productivity in our companies. You know, when we talk about Inventor libraries, the first one that pops to my mind is GrabCAD. I am a big fan of GrabCAD. I use it all the time. As a bit of homework, for those of you who are not familiar with GrabCAD, I really would encourage you this evening, when you get back home, go up to grabcad.com and explore this library. I can almost guarantee you're going to want to join the first time you start looking at really what's available up here. I mean, they don't care what CAD tool you use. They just want you to share your designs with the rest of the world. It's a great community to belong to. But when it comes to utilizing these online libraries, your local library has to take priority. As an example, if I want to use a library file from GrabCAD, I would need to download it, get it cleaned up, and stored in my working part library, my local component library. Then I could start utilizing the parts into production. Well, when it comes to libraries, there's a couple of things that go along with libraries. For instance, libraries need a librarian. If you're going to develop this workflow, you're going to need to have a CAD manager to help protect the data that's in the library. Now, parts stored in an Inventor library cannot be edited. You actually access libraries through the project file, and the project file calls out the library, and anything stored in the library cannot be edited. Now, there are workflows. If you absolutely have to modify the part, there are workflows to do it, but by default, you do not edit library parts. Library parts are seldom, if ever, revised. So before you go to commit the part to the library, make sure it's right, checked, and final, ready to be used. I mean, we all know we don't write in library books, right? If you disagree with the way the story ends, you don't just go in and scratch it out and write in your own ending on a library book. We just don't do that. Library books are reference material. They need to be the same every time they're checked out of the library. And your component libraries are just the same. This brings us to our second objective, and that is to develop an office layout using library components equipped with iMates. Now, in this demo, this is another instance where I need you guys to get your hands off your mice and pay attention up front. In this particular exercise, there's a couple of extra buttons I'm going to introduce to you. This is a little bit more involved than the previous exercise, so you definitely want to pay attention to my mouse clicks and my picks as I go through this demonstration. So I'm going to jump back into Inventor. We'll say goodbye to our little friend here. And I want to open up the exercise for this activity. I'm going to use File Open. And again, I'm going to go back to that workspace. Remember that little shortcut that always takes you to your workspace. And I'm going to open up the folder. There's a folder here called Studio. In the Studio folder, you'll find an assembly file called Studio IAM. Again, it has that assembly file icon. That's your exercise file. Go ahead and double click that and open it, and you're ready to start the exercise. Now our goal here is to actually do something useful with iMates. Look, I love playing with Legos, but I don't get paid to make Lego models. You get paid to put parts together in assemblies. So we want to do a real-world example of how we would bring parts together in an assembly, like, for instance, the classroom we're sitting in right now. Somebody figured out how to lay out this classroom, and we should be able to use Inventor to do this very well. This workflow, by the way, is very similar to what you do inside a Factory Design Suite, which is another tool that I get to use a lot. So the first button I'm going to introduce to you is the Place button. Up on the Assemble tab, the very first button in line is called Place. Some of you, if this is the first time you're going to go into this, it might say Place from Content Center. Use the little flyout and select Place to start the command. Now, in your little shortcut area here, your project file gives you access to my Inventor library. I went ahead and I installed the Inventor library on everybody's machine, so you all have it locally in the classroom. Ideally, the library should be on the network, but in our classroom, it is on your C drive. So you can easily get to the Inventor library. Now, here's what you have to remember. The data that you're going to use today is in a subcategory called Office Equipment. I wish you had time to go in and explore all my categories, but Office Equipment and then Classroom. Again, if you could reiterate, you want to go to the Office Equipment category and then into the Classroom subfolder. Now, the parts we're really going to be using are these two. You have a student desk with a laptop and a student desk with a workstation. We're going to be using the student desk with the workstation, the assembly file here. That's the one I'm going to use. So I'm going to click Open, and this brings the part into the assembly. Now, there's a little XYZ UCS symbol on the part that you're bringing in, and this is your opportunity to orient the design. So, for instance, I want to spin this on the Y-axis. I can just right-click. Before I ever drop it off, I can right-click and select Rotate Y 90, and I can orient the design the way I want it. So I'll simply left-click to drop one instance of that off, and I need 2 more students for this class, so I'm going to drop off 2 more instances oriented the same way. You can hit Escape to finish the Place command. Now, orbiting inside of Inventor, the Shift and the Wheel tool kind of reveals to us that the people are not on the floor. They're not lined up with the floor at all. And we need to, typically, we would add constraints to do that. But when you select these parts, I hope you see they have iMates that are ready to go. Now, the iMate that's off by itself, off to the side, that's the iMate you want to use that puts this on the floor. Now, here's a little secret with iMates. You don't actually have to have a corresponding iMate. For instance, I can drag this iMate over and just make it match to the floor. It's ready to go. So iMates do not have to have that corresponding bubble to make them work. So I'll bring over the next student. I'll make sure that that one's on the floor as well. Then I can bring these things close together. And now I can use the iMates like in our previous exercise. And I can mate these 2 desks together very easily. Now, in our exercise today, we're just going to place these flush by eye. We're not going to jump into the next exercise and flush them up perfectly. We're just going to get them close for this exercise. So I'll really finish up by dropping this onto the floor and making sure we snap the 3 student desks together. And again, all you have to do is just line them up by eye right there. Now there are other assets. If you have time, you can go explore. We won't have a lot of time here. But another asset you might think about is the projector screen wall mount. There's a little projector screen here. You can drop it right off to the side. Just right-click OK or hit Escape. And it has an iMate. When you drag this iMate, you want to go straight to the wall. You can constrain to the wall, just like constraining to the floor. And you can hang the screen right between the 2 windows. I'm not a big fan of putting my projector screen between 2 windows, but I want you to see how easily it would be to begin the process of laying out the classroom. If you have time, I'm going to encourage you to go, there's another category, if you go back up to the library, go into people. I've got a big collection of people. One of my favorite categories is actually called photo people. And I've got a number of just people that you can bring in. I've got a guy here, a man presenting shirt and tie. And this is a cardboard cutout of a person. We can spin him on the Y and drop him in place. And he has an iMate, and we can just drop in the instructor at the front of class, and we can drag him around and position him anywhere we want. All right, we zoom in close enough, you'll see it's actually a photorealistic version of a part or of a picture just sitting on top of like a cardboard cutout. So that is the exercise. All right, so now it's your turn. I want you guys to open up remember, go to the Studio subfolder. I want you to open up the studio.iam file and get ready to start building a real assembly utilizing iMates. Remember, you're going to use the place component command to place the office equipment and the classroom data into the room. Remember that right mouse button option to reorient the parts. If you forget that, there is a little free rotate tool. Anybody wants me to show you that during the exercise, I'll be glad to. But there's a free rotate tool that allows you to spin them after you've placed them. And if you have time, try that photo people option as well. All right, so again, we're going to take about 4 minutes, let you guys work through that exercise. And again, if you have any questions, definitely lift your hand up. I'll be walking around the class, checking out how things are going, and I'll be glad to work with you and to get this done on time. Well, again, fantastic, guys. I can't believe how efficient you guys are already with this workflow. I mean, you got so many different CAD engineers for using so many different products in this room, and you have all created an Inventor assembly today in next to no time at all. So I got the biggest question I have for you at this point: do you believe in Lego CAD? Do you believe that workflow is actually possible? I see a lot of you guys nodding, and I absolutely agree. I think with Inventor, even today, that Lego CAD mentality is actually a real-world possibility for my CAD tool. Now, if you believe that it's possible, I got a question for you. You believe it's possible, then how can this Lego CAD workflow be used to increase your current design productivity? How can you utilize Lego CAD back at your office to make your daily designs more productive and more efficient? You know, I'm glad to see so many of you agreeing and believing in Lego CAD. You know, just recently there's now a new song to promote Lego CAD. I think you can all sing along just as nicely as you can.
Everything is awesome. Everything is cool when you're part of a team. Everything is awesome when we're living our dream.
All right, I'm going to stop that there. That song will get stuck in your head in next to no time flat, so I'm not going to have you listen to that entire song. But I really do want you guys to, now that you believe in Lego CAD, I want you to go back to the office and put it into motion. All right, our next lesson is in the perspective view creation. For now that we've got these assembly files, we want to be able to drop them in place. So let's go ahead and get started on that.